Hey guys, what's going on? Jake here, coming at you with another math lesson today. Another live stream, getting ready for finals this week. So I wanted to do, a little bit more of giving everybody a chance to ask questions live. So, as we go through problems that I do have prepared for you guys, be sure to drop whatever questions you have in the live chat. I'll do my best to answer whatever questions you have, whether it's about the question that I'm doing or the topic that we're talking about, or even if it's something completely unrelated. If you're going through studying for finals coming up and there's something else that I'm not talking about that you want some more info about or want to see some examples on, please be sure to drop those in the live chat, and we'll see what we can do for you. So today I wanted to talk a little bit about implicit differentiation. I know I've talked a lot on my channel about that, especially over the last several weeks, but it's a tough topic and a lot of people have a hard time with it. I know I used to have a really hard time with it. So wanted to show you a bit more of that. And then I also wanted to just kind of talk about general study tips for getting ready for finals. So without further ado, let's go ahead and get started with an example here. Here is the first example, implicit differentiation, that I wanted to go over with you. So what we're going to do is we're going to find dy dx given this equation here, y squared equals 3xy minus x squared. So really with any implicit differentiation problem, any time you're trying to find dy dx, or the other really common one is like dy dt, but really whatever it is, if you're trying to find this like d one letter over d another letter, doesn't really matter what those two letters are. That right there actually gives you a ton of information that you're going to want to keep in the back of your head as you work through this entire problem. So what this tells you right here, if we're trying to find dy dx, d anything over d anything else, we'll just say d squared over d triangle, whatever these two things are, it doesn't matter. What this tells you is whatever this thing right here is on the top, that is going to be treated as a function. And whatever this thing here on the bottom is going to be treated as your variable. So in this case, we have dy over dx, y is a function, x is a variable. So I like to recommend writing this out right off the bat. Keep straight what's your variable, what's your function, because as you go through this problem, what you're going to do, whatever's your variable, whatever's on the bottom down here, you're going to find the derivative of both sides of your equation with respect to that thing. Sorry, got something in my throat here. So this is going to tell you exactly how you're going to deal with taking the derivative of these different pieces based on the fact that x is our variable and y is a function. And the reason why that is whenever you're taking the derivative of whatever your function is, in this case y, you're going to want to treat that, or you're going to want to find the derivative of that term using the chain rule, because we don't know what this function y is. So if you don't know what the function y is, you can't possibly know its derivative. We can't find the derivative of y if we don't know what y is. So what you'll kind of run into basically is whenever you're taking the derivative with respect to x of y, or whenever you're taking the derivative with respect to your variable of your function, you're not going to be able to actually find that derivative. Instead, you're just going to write that as dy dx, which literally just means the derivative of y with respect to x. So as we go through this now, let's kind of keep that in mind. Anything that just has x in it, finding that thing's derivative is going to behave the way that you probably expect. You're going to be able to use power rule, product rule, chain rule, quotient rule, any of that kind of stuff as normal. But anything with a y in it, we kind of have an extra step based on the fact that y actually represents a function rather than a variable. So let's go ahead and actually go through this derivative step of this example, and I'll kind of explain what I mean by that. So as we're doing this, we basically can just kind of go term by term and think about each of these three terms here, one on the left side of our equation and then two on the right side here. And as we go through and take the derivative of these things, we'll keep in mind that x is your variable. So when you're taking the derivative of y squared, like I said, y is a function. So really what we have with y squared is you want to think of this as a function of x, all being squared. So if you were trying to take the derivative of something like this, you would need to use chain rule, because you have a function here within parentheses, basically, being raised up to a power. So chain rule says we're going to take the derivative of the outside function, the derivative of this squared piece, and leave the inside alone. So we'll bring the 2 down in front, leave the inside function alone, which is just y, and then lower our power by 1. 2 minus 1 is just 1, so 2y to the first is just 2y. And then by chain rule, we have to multiply this by the derivative of the inside function. Well, the inside function is just y. And like we said up here, the derivative of y is just dy dx. Okay, then over here on the right side, we have, again, basically 3x multiplied by some other unknown function of x. So what we're going to have to do here to find the derivative of this term is use product rule, where we basically can treat 3x as one of our functions and y as our other function. And we'll just kind of break that down over here. So we'll just say f is going to be our 3x, g is going to be y. So this product rule formula, chain rule formula as well, both these things are on my Calculus 1 study guide. It is free. If you want to go grab a copy of that right now, you can do so. There's a link down in the description where you can get that for free right now. And that actually would be another great tool for you studying for finals coming up. So go grab that real quick, pull that up, and I'll show you, this formula right here is just the product rule formula, which is on there, which basically just tells us to find the derivative of f times g, 3x times y. We need to figure out the derivative of each of those pieces, first of all. So the derivative of 3x with respect to x, we're taking d dx. So derivative with respect to x of 3x is just 3. And then the derivative of y, again, is just going to be dy dx. And then product rule says that we're basically going to multiply these across and then add them together. So we're going to get 3x times dy dx and then 3 times y, and then add them together. And then for taking the derivative of minus x squared, that's just going to be straight up power rule. That's nice and simple. Bring the 2 down in front, lower the power by 1, giving us 2x. So now, really, with any implicit differentiation problem, the next step that we want to kind of go to is to separate our dy dx terms on one side of the equation and our non-dy dx terms on the other side of the equation. So you can see, basically, thinking about the different terms we have here, we've got one term here with dy dx in it, one term here with dy dx in it, and then one term here without a dy dx, and one term here without a dy dx. So basically, we want to get these dy dx terms over on one side. We'll leave the non-dy dx terms over on the right side of our equation. So basically, we'll just have to subtract this over to the other side. Or in other words, just subtract it from both sides of the equation. It'll cancel over here, and we will have 2y dy dx minus 3x dy dx equals 3y minus 2x. And then once you have gotten all of your dy dx terms on one side of the equation, typically what you want to do at that point is, since now everything on the left side here has a dy dx in common, what we can do is we can factor that dy dx out of the left side of our equation. So pulling dy dx out of this term is just going to leave us with 2y. Pulling dy dx out of this term is just going to leave us with minus 3x. Right side is not going to be changed at all. And then now the reason why this is so nice is now we've gotten this to the point where we only have a single dy dx. So what that means is all we can do to basically get that all by itself is just divide all the other stuff that's in parentheses here from both sides of our equation. And that's just going to leave us with dy dx equals 3y minus 2x over 2y minus 3x. So that's really it. Any implicit differentiation problem is going to follow that exact same process, those exact same steps. You're basically just going to keep track of what's your variable, what's your function, take the derivative of both sides with respect to your variable, which means whenever you see a y, you need to treat it as an unknown function of x, which usually is going to require the chain rule. Then you add or subtract all of your dy dx terms to one side of the equation, all of your non-dy dx terms to the other side, factor out a dy dx, and then divide all the other stuff to the other side of the equation, and dy dx should be by itself solved for at that point. So like I said at the beginning, if you do have any questions, feel free to throw them in the live chat there. I'd be happy to help address whatever questions you guys have. But I do have one more implicit differentiation example to go through with you. Before we jump into that, though, I do want to just take kind of a quick moment to just kind of talk about some study tips for how to study for a calculus final, because I know that's something that a lot of people have a hard time with, is how to study for math. So I'd say there's probably two main things that I used to use a lot when I was a student that were a huge help to me. So first of all, I think it's a big help to keep some sort of a formula sheet, a cheat sheet kind of thing. It doesn't necessarily have to be just formulas that you're going to memorize, but also put other stuff on there like, for example, we just did this implicit differentiation problem here. Write out the kind of 4 or 5 main steps that you go through with implicit differentiation problems, or other common types of problems like related rates problems. Those can pretty much be broken down into 4 easy steps, which I've made several videos about. I recommend going and checking those out. But my point is, if you can, write down all the relevant formulas, so you can just kind of go through your textbook chapters, in order that you went through them in class, and write down the important formulas that are going to come up, or that that you've used a lot. And then also write down kind of almost like little cheat sheet steps for different types of problems too. So just kind of compile all this basically into one big sheet or formula sheet, and keep that next to you as you study. If you do get to use something like that on a test, that's even better, because I know a lot of teachers or professors do allow you to do that. And that's even more helpful, obviously. But keeping that next to you as you study is going to be a huge help to you. If you, are running out of time, need to go get something really quick because you got a test coming up tomorrow or something, I do have a Calculus 1 cheat sheet study guide. It is free. You can go grab it. There's a link down in the description down below. So just click down there real quick and go grab that and pull it up real quick, and or even print it out and add to it. I mean, you really want to kind of add the things that you need onto there, basically. The other thing that I think is, in terms of actual process for studying, the way that I went about it, and that was really helpful for me. Once you have your cheat sheet and your formulas all next to you, you pretty much just need to practice by doing problems. So go through, textbook notes, whatever it is, and figure out examples basically of all different kinds of problems, which is going to be following a similar structure to the cheat sheet that you just wrote out. That'll kind of give you a hint of what topics you need to study, and then go find examples. Start with the easiest examples and kind of work your way to harder and harder examples. The only way you're really going to get this stuff down is by doing it over and over and over. And I know that can seem tedious and feel like it takes a long time, but really that kind of repetition of going through a variety of different problems and making sure that you're getting harder and harder problems as you go along is really the only way that you're going to be able to really gain a solid understanding to the point where you're going to do well on an exam or a test. So that's what I used to always do. That, worked really well for me, and I've seen it work really well for a lot of other students. So that's kind of what I'd recommend. Again, if I do also have a complete Calculus 1 package that has a lot of that kind of stuff in it too. So if you're kind of crunched for time, you can go grab that as well. There's a link to go grab that in the description too. So I do have some helpful resources for you guys if you need them. Just go click those links in the description and go grab yourself digital copies of those things. They're available right away. Don't need to wait for shipping or anything like that. So hopefully you find those tips helpful. I know studying for math can be a little bit weird and challenging compared to a lot of other topics, but that's kind of the process that I would do when I was a student, and it worked really well for me. And I know I've kind of recommended that to lots of other students, and I think it has worked well for a lot of other people too. So give it a shot and let me know how it goes. Good luck. But let's go ahead, and I do have one other example here that I wanted to talk about, one more implicit differentiation example. So let's go ahead and go on over to that one here. And then, like I said, if you do have any questions, even if they're off topic, throw them in the live chat. I'll do my best to answer whatever questions you have. Doesn't have to be about implicit differentiation or finals or anything specific, as long as it's on the topic of calculus. Well, even if it isn't, gotta have some fun every once in a while. If you got a completely unrelated question, go for it. But let's go ahead and jump into this example here. So again, just like we did in the last example, first thing you want to think about, what is your function? What is your variable? Well, since we have a y on top here, y is going to be our function. And we have an x on the bottom. X is our variable, right? That's all there is to it. Whatever is on bottom is your variable. Whatever's on top is your function. So basically what we know right away, right, based on what the problem is telling us to find, we're going to need to find the derivative with respect to x, because x is our variable, because x is on bottom here. So we're going to take the derivative with respect to x of both sides of our equation. So, actually there probably is two different ways to do this problem specifically. We can just go right off the bat, take the derivative with respect to x, and we'd probably have to use quotient rule over here. One other option we have is, instead of taking the derivative right away, we can rearrange this equation a little bit, and that might actually get it into a format that's going to be a little bit easier for us. And what I mean by that is, if we think about how to get rid of this fraction, because quotient rule can be kind of messy, we would basically just multiply both sides of our equation by x, and that would cancel the x down here and move it over to the right side. So we would get x minus y equals 16y times x. So I think, honestly, this is probably going to be easier to take the derivative of with respect to x. So that's what I'm going to do in this case. If you want some practice with quotient rule, definitely, do it the first way. Quotient rule is another one of the formulas on my free Calculus 1 study guide. So if you need that, go grab it. Link is down below in the description. But we'll go ahead and take the derivative with respect to x of this equation. So we're not going to do that one. Instead, we rearranged it into this equation that'll be a little bit easier to take the derivative of. So basically, we just want to kind of think about each of these terms as we go in here. So the derivative with respect to x of x is going to behave the way that you would expect it to, right? The derivative of that is just 1. And that's because x is our variable. However, the derivative of y with respect to x is going to be a little bit different, because y is an unknown function of x. So we really have to treat this as the derivative of y with respect to x, the derivative of some unknown function with respect to that function's variable. Since you don't know the function, you can't possibly know its derivative. So the best we can do here is to say the derivative with respect to x of some unknown function y is just going to be dy dx. And that's going to be consistent as we go through these implicit differentiation problems. Then, to take the derivative of the right side of our equation here, we are going to have to do product rule, which is also one of the formulas on my study guide. But we'll go ahead and say that 16y is one of our functions and x is our other function. So we'll say f is 16y and g is x. The derivative of 16y, again, we don't know the derivative of y, but what we're basically going to be able to do is just say this is going to be 16 times dy dx. Because the derivative of a constant times a function is just going to be that same constant times the derivative of the function. And the derivative of y, like we set up here, is dy dx. Then the derivative of x, again, that's going to behave exactly the way you would expect it to. Derivative of x is just 1. Sorry, that was kind of cut off there. So now product rule says that we would just basically multiply across here. So we're going to get f times g prime, so 16y times 1, which is just 16y. And then 16 dy dx times x, and then we'll add those together by the product rule. Product rule says you multiply across and add them together. So 16x times dy dx. And now what we want to do, now that we've taken the derivative of both sides of our equation, we just want to add or subtract all of our dy dx terms to one side of the equation, add or subtract all the non-dy dx terms to the other side. So we're going to subtract 16x dy dx from both sides to move it from the right over to the left. And then we want to subtract the 1 from over here to move it over to the right. So that'll cancel there. And we will be left with negative dy dx minus 16x dy dx. And then on the right side, we're going to have 16y still, and then minus 1. So now that we've gotten all of our dy dx terms onto one side of the equation, all of our non-dy dx terms to the other side, we will factor out a dy dx from the left side of our equation. Factoring out a dy dx from a negative dy dx is just going to leave us with negative 1. We do need to have this negative 1 here to kind of hold the place of this term that was here. And then factoring out the dy dx from this term is going to leave us with minus 16x. And then on the right side, we did not do anything, so that's not going to change. And at this point, we have only a single dy dx term. So to get it all by itself, we just have to divide whatever's in the parentheses here over to the other side. So we will get dy dx equals what was already on the right side of our equation divided by what was within the parentheses here. And that's going to be it. I mean, we could simplify this a bit if we multiply the top and the bottom by negative 1, just so that there's less negative signs. Negative 1 divided by negative 1 is just 1. So it's not going to change the value to multiply the top and the bottom by negative 1. So doing that is just going to give us dy dx equals 1 minus 16y over 1 plus 16x. Yes. Cool. So that's really it. There isn't going to be any more simplifying we could do there, and that solves for dy dx. Anybody got any questions on any of those? I'm not seeing any questions in the live chat, but if you do have any questions on either this problem or anything else as you're studying for finals, go ahead and throw them in the live chat there. Happy to help answer any questions you have. I know it's finals coming up, finals week for a lot of us. So if you do have questions, throw them in the live chat. We'll see what we can do for you. Hope everybody's week is off to a good start here. Made it through Monday. Also, I am hoping to have a couple more live streams this week since it is finals week. I want to give everybody a chance to get all their questions answered. So if you be sure to subscribe and hit that bell icon down below so you know when I'm going live. I'm not exactly sure which days or what times exactly I'll be doing them. So make sure to subscribe to my channel so you know when they're coming, so you can come and join us again later this week. All right. Not seeing any questions. That's all the questions I had prepared for everybody ahead of time. So if nobody has any questions, we'll go ahead and wrap things up there. Hope everybody has a good rest of their night. And like I said, be sure to subscribe so you're notified when I go live throughout the rest of the week. And we can get those final scores up high. And if you haven't already, please be sure to hit that like button down below too. It's a huge help to get this video out to more people and help grow the Jake's Math Lessons community so we can all do well in calculus together. So hit that like button, hit that subscribe button. Thanks, and we'll see you next time.